So welcome to the meeting of the Kubernetes IoT Edge Working Group on the North American time cycle. This meeting abides by the Kubernetes Code of Conduct. The summary of that is just treat others as you'd like to be treated yourself and be nice to each other. With that said, I think we had a carryover item on the agenda of Tina talking about Acrano, but she isn't here yet. So we'll wait to see what happens. And we started, before the meeting started, with a little bit of sidebar discussion with Greg about the concept of using Kubernetes. He's got something going with a cloud-hosted central control plane, trying to manage things out at edge. Am I restating that right, Greg?
Yeah, that's right. It's actually very much like that slide you were showing just before we officially started. That yeah, we have an independent Kubernetes, well, not completely independent, but a central Kubernetes cloud kind of deployed in the core, and then there's edge clouds like control plane and everything that are much smaller that are deployed, yeah, like not way at the edge, but kind of close to the edge for providing edge functionality. And then in theory, what we'd like to move to is to be able to also have those, near edge clouds managing, far edge devices.
Uh-huh. So I notice Yin has joined the call, and he's affiliated with the KubeEdge project. And you had a few questions about it before the meeting started. So he's actually an authority on that. If you want to, if you have any questions about KubeEdge, go ahead and ask him, because I think if he might be driving and unable to talk, but he might be able to answer any inquiries you have.
Yeah, I think it's more just I need to just take a look at KubeEdge. I don't think I know enough to ask any reasonable questions yet, but unless you can give like the 5-minute overview of what KubeEdge provides.
Yeah, maybe he can actually give some tips on getting started then, like how you would go about doing an eval or something like that.
Yeah, sure. So you want to modify or just use a KubeEdge?
Well, I'm not sure yet. Like I say, we're using kind of the full Kubernetes deployment in both our central cloud and edge clouds, and just I didn't know whether KubeEdge was kind of a different Kubernetes distribution that you'd potentially deploy at the edge for
no, that's probably micro Kubernetes or K3s. So Kubernetes is, you can think about Kubernetes is just workload on the remote edge site. So we deploy standard Kubernetes, so in the cloud. Then we have a KubeEdge deploy on top of a Kubernetes. So basically you have a cloud part and you have edge part. So instead of a standard Kubernetes, so we modify and simplify that a little bit. It's called Edge Core. Then you use the Edge Core to join the Kubernetes cluster. Our edge part called Cloud Core, that's basically a proxy or adapter to track or process all your requests and translate to the standard Kubernetes API to call the API server, register on the etcd. Basically, from the user point of view, is standard Kubernetes API. You just use the kubecontrol apply, kubecontrol deploy, or kubecontrol logs, kubecontrol, everything. We just support standard. Basically, you still talk to the API server. And so nothing changed from the end user. For the operating, DevOps or admin of Kubernetes side, what you view is a standard Kubernetes with a add-on, then all your workload on the remote.
I guess I don't feel so bad, Yin, because I sort of started down the road thinking of the concept of KubeEdge being a distribution myself. So maybe the documentation isn't super clear, or maybe there's old stuff out there that represents it wrong. But yeah, Greg, the concept is that you get some Kubernetes distro of your choice, and then you can layer the KubeEdge functionality on top of it. So that's correct, isn't it, Yin?
Yeah, you choose any. I think the community version of KubeEdge only support open source Kubernetes. That means if you deploy on EKS or AKS, you have problems because they have a strict requirement on how they are going to control the nodes. So because
right, so you need full admin credentials, in other words, because some of those as a service ones, the cloud provider owns it, not you, or at least they own key parts of it.
They prevent us from controlling the node because we want to join remote node, right? They said, okay, we cannot allow you to do that.
So is the objective is that you to minimize like the footprint that you need on the remote device?
Yes. So let me put. Also, I post our due diligence our presentation for the SIG runtime for the CNCF. So in the slide 3, you can see. Do a quick share. Okay, Steve, you may be able to show the slide 3.
Let me let you share. I'll make you a co-host, if that helps you. I don't know if you want to show the slides.
Yeah, sure. It's just quickly show. So these slides show the overall architecture. So you can see in the middle is the, how do I have that? So in the middle, you can see the standard Kubernetes, and the user use standard Kubernetes control. Then you talk this cloud core part. We have our own CRD controllers, device controller, edge controller. Then you talk to this is cloud core is a simplified version of Kubernetes. So then we derive from the Kubernetes. So in adding all this CSI or CRI. So basically, this one is the open source version of Kubernetes, or you can try on EKS or AKS, but they need to give you the permission.
Okay,
So
and does the edge device show up as a worker node in the
it's a device. You have a device CRD.
Oh, okay. So there's a list of CRDs that are basically running KubeEdge.
Yep.
Okay, and then do the CRDs support a mechanism to deploy containers on the devices?
No, not yet.
Okay, but
well, wait. Can you go back to that drawing? So below that red dashed line in the middle of the slide, it's the dividing line between the cloud hosted and the edge hosted. So below the line at the edge, you do have a container runtime. So it looks like it does run containers, right?
Yeah, I mean, I think Greg's question is a run container on the device instead of the edge.
Oh,
no,
okay.
Can from the central cloud, like above the red line, can I deploy a container on the edge node?
Of course, yeah, you can. You can assume this is just the regular worker node. Whatever you want to deploy on the cloud worker node, you can do on the edge node. I just say we don't support on the bottom right. That's a device.
Yeah, I understand that. But actually, maybe just back to my original question, because maybe I asked it incorrectly. The edge, like the bottom left, does that show up as a worker node in the top cloud or as a device controller?
On a worker node, as let me see if I have a screenshot. Yeah, I don't have that right now, but if you do the kubecontrol get node, you will the edge node is show as a edge node. As
Oh,
a
really?
node. Yep.
Okay. So even though it's not running the full Kubernetes distribution, it's running kind of KubeEdge, it still shows as a node in the top Kubernetes.
Yes.
Okay,
So basically, we have the
oh, I kind of see that at the top. You have cloud
we
node.
can have the edge controller basically just translated to the API server, then we install that on the etcd. So the Kubernetes will.
So Greg, in anticipation of some questions you might have, I mean, if these devices, if you've got things running your Wind River non-Linux like OSs, which I think there are some, they would fall in that category of devices. But
Yeah, like
maybe you've got some that would be capable of being Kubernetes nodes if they're Linux-like enough to manage to install them as a Kubernetes node.
yeah, actually, we have two embedded OSs. We have one that is like a carrier grade embedded Linux. We call it Wind River Linux, and it can run Kubernetes. But we also have a really old, like I don't know, must be like 40 years old, embedded OS called VxWorks, and it's super popular, and like it still makes us tons of money, and yeah, it definitely cannot support Kubernetes. I think it might be able to support containers, but definitely not Kubernetes. So yeah, for all our VxWorks devices, they would fall in the bottom right corner of that previous diagram.
So Yin, another question that I think is going to come to people's minds is for KubeEdge, there are going to be some edge use cases where you've got 5,000 or way more than 5,000 nodes out at edge. And I believe that's the upper limit on how many cluster nodes you can have in a Kubernetes deployment. What would be the preferred resolution of that if you had to deal with it?
Currently, we do the multi-cluster deployment. You can see one of the in production, they have a 50,000 edge node.
Okay.
But here we have multi-cluster in the central cloud, Kubernetes cluster deployment.
Oh, but it's okay. So it's multiple Kubernetes clusters, like separate control planes. Like a cluster is a separate control plane, masters and stuff. But it's not geographically distributed. It's just for scalability reasons that you're using multi-cluster in the central area there.
That's correct. But the edge node is geo-distributed.
Understand, yeah. Okay.
And then I imagine if you can federate in the cloud, do you also have a story where you could land full independent Kubernetes clusters at edge and then federate those?
We think about that. We don't want to make that too complicated. Like I said, the footprint of edge control plane is very light. So
like how
here all the control plane take only about 60 megabytes. So we fit in a very small edge node. We want to limit it, and then we don't want a very complicated, architecture. We want to offload all this to the central cloud. So you may have a fat Kubernetes cluster deployment in your central cloud to solve this multi-cluster problem. But we don't want to do this because we thought about that. But I think you need to synchronize all the status from edge to one layer.
Yeah, the federation across a boundary with intermittent connectivity might be a challenge.
Yeah, so we said, okay, let's do you can have your KubeFat to do a federated Kubernetes deployment to increase the capacity or something like that. So we don't want to, put all this complicated logic in this edge cloud communication.
Hey,
We want to simplify that.
How small did you say the a server needs to be for running your edge nodes? You said only it can go as small as 60 megabytes?
That's our management plan.
And like how many cores do you need? Like as far
That's
as
one core.
one core.
That's for the smallest IoT gateway.
Okay, so do you actually deploy? Do you actually have small servers that, like, what, 2 or 3 core servers that you deploy your edge node on?
Yeah, we do have a 2-core or 4-core server, and we also can, as small as a Raspberry Pi, or even smaller, we have some MIPS IoT hubs. They deploy our edge. So we need a minimum 256 megabytes to deploy containers on the edge. But if you only have 128 megabytes memory, we support you deploy some process instead of containers.
Okay, I thought you said 60 meg earlier though.
Yeah, the 60 meg is the control plane.
Oh, okay. So as far as the server itself, it'd be typically like an example would be 128 or 256 meg.
Yeah, ideally it's 256 megabytes if you want to run container, because the Docker runtime or other CRI.
And then you typically have what, a 2 or 4 core server or something like that?
It depends. We varies, right? If you do the IoT, it depends on your workload.
Yeah. Okay. I was just kind of getting the ballpark. Yeah, that's pretty small. Because like what you guys were describing there a second ago was basically the route that we've gone, is that we consider our edge node a little bigger. So we
definitely do bigger ones. So we do.
Yeah. But because I guess we've taken the assumption that, for the use cases that we're trying to address, that edge node will be bigger. So we actually deploy our multi-cluster geographically instead of centrally like yourself. But like I say, I think it's probably like a different use case. Like there's some use cases that only KubeEdge could address because the server requirements at the edge are so small. But yeah, we do the multi-cluster geographically. But I'm kind of thinking that maybe it would be nice to have an option to kind of leverage an edge node as well as.
Yeah. Just out of curiosity, Greg, how big a platform are you currently targeting for edge, in terms of cores and memory?
Yeah, the smallest one that we use, because some of our customers, all of their edge nodes are single server clusters, like master and worker node all on one server. And we use I'm not sure how much memory it has, but we use the super micros that have the single socket 8-core Xeon D. And I don't know how much memory it has though, but I'm sure it's way more than 256 meg. It might be like, I don't know.
Yeah, these days it's actually tough if it's like an x86 motherboard to actually get a memory strip that's any smaller than 4 gigabytes.
Yeah. I'll look that up because I'd like to compare it to kind of, this kind of KubeEdge size sort of thing. So yeah, so right now our main customers are using a single server. I think it's sort of a Supermicro type server.
Yeah, speaking of small edge devices, this might be off topic, but I threw it out there anyway in the chat. I pasted a link to this small system put out by Seed Studios, and it's got both an x86 and an ARM processor on it, 2 gig Ethernet ports, 2 PCI Express sockets, a SATA bus, and I think it's around $200 US.
Mm.
Oh,
I just ordered one about 2 days ago, so I'm waiting for it to arrive.
have you compared that with Raspberry Pi or?
I think that's substantially higher than a Raspberry Pi because it, first of all, by moving up into x86, it's a 4-core Celeron. And
Yeah, that's
then
pretty
in
nice.
addition to that, it has like an Arduino class ARM processor on it as well. And I think they put the Arduino bus, IO bus on it.
Yep.
So it looks pretty versatile.
Yeah, if they put a GPU or
Yeah,
GPU
no
there.
GPU, but there are 2 PCI Express slots, the mini ones that you would often use for either SSDs or Wi-Fi. Oh, and it also has an eMMC SSD.
Cool.
So that thing is, I think, up into the low-end NUC class, as
So,
opposed to a Pi.
I talked to Greg. It's just you see in our example in this, if you have AI process on edge, this one actually have 8 cores with, I think maybe it's bigger. It's 12 cores. I think they use 12 cores plus 2 GPUs on this to run a smart video processing. So we support a bigger edge too. So you can give it a try.
Right.
Yeah, I kind of think the trend is, especially if you look at, I've never heard of anybody using literally cell phones as a platform, but you look at cell phones, just mid-range ones, and how many cores, how much RAM, and the fact that they do often have GPUs, and they should be refactorable into a pretty plausible system for edge.
Yeah, yeah. So what are, in the KubeEdge, like on the Edge node, what are the protocols that you're using to talk to the devices? Are you using like Edge Foundry and stuff like that, or have you developed your own apps? Yeah, like that. What is that, Mosquito? Is that the MQTT?
Mosquito, we do
Yeah.
we support.
That's MQTT.
Okay.
That's the 3.1 we supported. And in the community, they are proposing to modify that to support more flexible, to support more protocol or customer-defined protocols. That's we just have a proposal yesterday in the community meeting. So we are going to upload that meeting notes, meeting recording to the YouTube.
So are you using open source packages for that Mosquito stuff, or is that
open source?
Okay, and is it Edge Foundry, or is it? Okay.
So Mosquito is an open source project unto itself. I forget whether it's hosted by a foundation. I think it is, but
it's Eclipse.
okay.
Yeah. And I would be remiss to not mention all of the Eclipse IoFog and all of the Edge stuff happening over at Eclipse too, Greg, too, that you should check out as you dive into this area.
Okay. Yeah.
So
That's good.
we had an item on the agenda of a Crano. Is anybody here as speaker for that topic? Or if not, we'll continue on our free form rambling, but okay, I guess not.
Yeah, I have a meeting conflict. I'll drop early. So Greg, if you
Okay.
have any questions, just, ping me.
On the working group Slack.
Yeah, or you just email. Yeah, I think you can find me, hopefully.
Yeah.
Yeah, or just.
Okay, well, thanks. Thanks for jumping in there
you.
and answering some questions.
See you later.
So Kilton, I hope you're recovering from your illness.
I am, and I was just thinking, so if since Yin had to drop off, Greg, if you want to continue to talk about edge architectures here, we can switch over to talk about Eclipse IoFog and compare and contrast a little bit if that helps you. But if there's other topics that people want to have, we don't have to hang on just this one the entire time. But thank you, Steve. I am feeling better, and I was just overworked. I didn't have COVID, yep, recovered.
Okay, anybody else want to jump in and nominate topics? Maybe we'll continue on with Greg's, but as always, we've got an open agenda and still 30 minutes left. So if you have others, either put the thing in chat, announce it verbally, or write it into the notes document. So far it's silent, so Kilton, why don't you go ahead? I think, did you catch Greg at the beginning on what he's looking at in his use case, or do you want to?
No, just a bit, because you guys were already underway when I hopped on, but I saw that your presentation about the CRDs, and honestly, I think that is definitely the right approach. And Steve, you and I have talked about this kind of at length, which is, CRDs is the right mechanism for extending Kubernetes to be aware of things that are not kubelets.
Yeah.
And so that.
So as a recap, Greg started saying that he's affiliated with Wind River, and that he's been looking or actually working on an architecture that has a centralized Kubernetes control plane, trying to manage devices and containerized workloads out at edge locations. Is that a fair representation, Greg?
Yeah, that's right. Yeah, and I think you might have caught that. Yeah, we deploy at the edge. We deploy like a full Kubernetes cluster, but then the idea is that we can manage containerized workloads on that cluster, which could and is typically as small as a single server. But then we'd also like to extend, and I'm kind of thinking the same as you guys, extend through, CRDs to represent devices, to manage devices that don't have a kubelet, and you need to talk to them over various IoT type protocols like MQTT and that sort of thing.
Yep, makes perfect sense. This is so we've talked about KubeEdge. Let's talk a little bit about Eclipse IoFog and compare and contrast a little, and then you can have several options to look into here. By
the way, Kilton, I made you a co-host, so if you're free to just do it verbally, but if you want to share anything, you should be able to.
Okay, thank you. Yeah, I don't know that I'll have a presentation here to share, although if you give me just a moment, I might. So when you are getting out to the edge, we've already mentioned, this kind of the upper limit, 5,000 nodes being where you start to think that, this is known to break down. Well before that, I would say, 5,000 devices at the edge needs to be managed a bit differently already. You need a different awareness of what's going on there and how those devices are operating and what capabilities and stuff they have. So the idea of Eclipse IoFog is that you can use Kubernetes to issue the commands and orchestrate, but it has a different control plane, a different type of intelligence for working with the edge nodes and interpreting what's going on there. And that's because, for example, you might want to orchestrate to an IoT gateway that has an Intel Myriad X, AI accelerator. You might want to orchestrate down a container workload that is different than an IoT gateway that's basically just CPU with 1 gig of RAM, right? And all you want to do there is put maybe the a protocol adapter or something. And so that type of intelligence about what the edge nodes actually can do and what's happening with all of them, that's part of the Eclipse IoFog project. And then instead of a full-blown kubelet, there's a specialized edge agent it's called IoFog agent that is very lightweight, and it's similar in weight to what Yin was describing with KubeEdge. It's designed to be on devices that are 128 megs of RAM, running a simple container, on things that have a couple hundred megs of RAM, and then up from there. Although the agent pattern is suitable for implementation in in anything, including microcontrollers that just have firmware, because it's a communication pattern back and forth, and then the agent implements what needs to happen on the edge. It either runs the containers or runs the serverless functions or starts the Python script, or calls the library, whatever it is you want to execute there. And so the communication between the edge nodes and and the control plane is expected to be sporadic, and it's expected to be constrained. This is designed from what we're calling the Eclipse Foundation Edge Native, which is we obviously want to be in partnership with all of the Kubernetes community stuff, given that name. For our architecture, Edge Native means that you assume right from the start that the device that you're running on may only check in 5 times a day, or even once a day. It might be over satellite backhaul or something. And so the work that you want to do with the controller can be made very lightweight and can be tuned. This is not in contrast to the concepts of bringing Kubernetes to the edge with a cluster down at the edge location, but it is in contrast in terms of the implementation, just assuming that it's just too heavy to communicate the same old way and have things that are designed for the edge. More than 5,000 nodes is not a problem, right? So it's tens of thousands of devices is what's expected, because the communication is very lightweight. Let's see, why don't I see if I've got here a presentation that I could share, and that would probably help things a bit.
So the IoFog agent is a requirement on the device?
Yes, some form of IoFog agent on the device is a requirement, and then you choose the runtime that you want for like containers or whatnot. And then everything that you have, all of the IoFog agents and so on, they're all infrastructure as code. So you can kind of roll on and off edge nodes, et cetera, et cetera. Let me...
You haven't got any resistance to the IoFog agent? Like, I know sometimes device vendors don't want any software other than their own running on their devices.
Generally, the agent usually installs on top of things. And so generally it is the end user of a device that wants to run IoFog and put it on their super micro IoT gateway or their Raspberry Pi or whatever. Okay. The nice thing here is that, I just realized what you were probably asking. You do not need an IoFog agent on the end device if it's not intended to run orchestrated workloads, but rather is something you just want to connect to, such as a Modbus over Ethernet, pump controller or this or that.
Okay, so you get some level of monitoring or control even without the IoFog agent on the device.
That's right. Yeah. So here, let me share my screen and see what I've got here. Frederick, you're probably going to laugh because this is just the one that I just sent you is what I have handy for IoT World this week.
I would never dream of laughing at you.
Anyway, we can see it. Okay,
great. So yeah, let's see here. There's this is probably the best place to start here. So it's our belief, and our meaning mine from 2014 and sticking with it, that there is a limit to what things in an IoT / edge computing / smart device deployment scenario, there's a limit to what things should be smart enough to run arbitrary code. Then there are things below that line that are, well, they should probably stick with their firmware or whatever it is that they're running. Maybe they're RTOS, and everything at that line and below is leave it as it is. Don't make changes to the device. Let it speak the protocol it speaks, etc. And so how on earth do you integrate it then? Well, an edge compute node such as an IoT gateway is a perfect place to be running they can be very lightweight, but running edge processes that are intended to do the interfacing with things that already speak their own language. And this is inspired by, you know, some of the industrial IoT challenges that you know, we all know. When you step outside of a certain, you know, protocol, if everything's OPC UA and compliant, you know, it's generally good. And then there's that device that's a 40-year running device that everyone still uses because it's great, and it kind of has its own byte order, or you query its Modbus registers and you can't make sense of it fast enough up in the cloud. You've got to take some action at the edge and parse those bytes and do something with it. And so in my view, edge computing, a big part of edge computing is moving critical processing that's low latency, et cetera, right to where the device is to speak its native language, such that you can represent it upstream. You can make a digital twin and the, you know, cloud, you can do all that stuff, but something has to talk to the thing. Otherwise, everything has to be greenfield and from vendors that want your, you know, your agent or your interface or speak a protocol perfectly. Even the Bluetooth field is littered with stuff that says it speaks to protocol, speaks the GATT profile properly, and then you get the bytes. And you're like, they're little endian instead of big endian. That's not how the Bluetooth SIG has defined it, but that's what I'm getting. And so how do I deal with this, right? Well, it doesn't work in the app anymore. Now you need something at the edge to interface and interpret. So this is a diagram of kind of like, this is a little bit outdated at this point, of what the agent does and how it, you know, provides stuff on the edge node that you can then come to rely on. Upstream from here, I think I've got this in something like, there we go. Upstream from here, and this is a really outdated diagram, is you can use Kubernetes to do the orchestration, but it will go through the IoFog control plane and out to the edge nodes as in a very edge fashion. And then the stuff that you've orchestrated will get executed, but with an extra layer of intelligence. What we're still working to do and trying to figure the right way to do it and gather some more help around it is really leverage CRDs from Kubernetes, such that an IoFog Edge is not even about extending the Kubernetes cluster. It's really about plugging in an edge that can be managed centrally. So you don't worry so much about what resources allow you to run Kubernetes at the edge. It's rather Kubernetes stays where Kubernetes was designed to stay, and the edge is an edge, and it plugs in so that it's completely visible. We have lightweight version of this today with Eclipse IoFog that you can plug in with Kubernetes. It doesn't matter which distro, commercial or whatever. And but we're really trying to figure out an architecture that when you look at it, you say, that basically can fit everything I'd ever want to fit. The model is good, and so have some plans. Just been super busy getting IoFog 2 out the door. There's one more piece that I'll talk about, which I think is relevant here. So the agents out there on the workload nodes, those are talking to devices that are just devices doing their business. Communication is key. And another belief of mine is that you shouldn't actually have any specific protocol embedded into the communication infrastructure, but rather you can stand up whatever you want. You've mentioned, you've asked Greg, EdgeX Foundry or you know, MQTT or what do you have going on at the edge? And I think the answer should be whatever it is you pick. In fact, with the IoFog control plane, it can be whatever we automatically deploy upon sensing devices that register, you know, as a certain device that speaks a certain protocol. So if you're, you know, looking for something with Bluetooth low energy, we automatically deploy an interface layer for that. We can deploy the Mosquito MQTT broker when we detect their devices that need it. But then what if you're wanting to work with EdgeX Foundry? Great, put those microservices down as your interface. And then what if it's something custom or, you know, just OPC UA and you just want to, you know, have one adapter for that and skip all the rest? That's all of this stuff is a fit. The communication from edge node to edge node is where it really starts to get interesting. We just finished implementing an integration with Red Hat's Project Scupper, originally designed to be multi-cloud. It is now multi-cloud, multi-edge, because when we were talking to them, and I think it was even in this working group that we had a presentation maybe about a year and a few months ago, which is really what kicked off the whole effort. And we were talking about it at lunch down at KubeCon San Diego last fall. Hey, remember when we all used to get together in person? That was some good planning we were doing. Well, now it's been released. And so the whole point is,
can you maybe add some color on what you mean by multi-cloud, multi-edge? Because
yeah, sure. So Scupper was designed to move arbitrary traffic safely, securely, and dynamically from one environment to another, such that if you had, whether Kubernetes controlled or not, if you had a cloud environment on public cloud, and then you had a private cloud, and maybe even a private data center environment, and you wanted to move data between points in there, but you wanted those points to be registered in something like what you would call kind of a central dynamic endpoint registry, this would be normally tricky, or you would need all traffic to be like pub sub and going through some cloud endpoint or whatever. One of my favorite protocols that's really undervalued is AMQP 1.0. Not talking about 0.9. I'm talking about 1.0, the kind of the full vision AMQP, which is a very different protocol than the 0.9 that's been beat up all these years. 1.0 is really versatile and can carry any traffic, but it's a layer 7 protocol. And so Red Hat's project Scupper is what they call a virtual application network, a VAN. And it's layer 7 network, software overlay network, that allows you to move data of any type from one point to another, no matter what NAT layers and firewalls they're behind. When I saw that it was really flexible and had intelligent routing, and you could change the topology of routers, and you could assign credits such that you had kind of a costing mechanism and so on, I was like, okay, hands down, best thing I've seen, great. Let's replace IoFog's lighter weight version of this, which it had for years, with Scupper. So we just finished doing that with IoFog 2.0, which is now generally available. And so what that gives you is, if you have an edge location, such as a cellular backhaul driven oil field, and you want to talk to those IoT gateways and deploy container workloads, then they talk over that cellular backhaul to the IoFog control plane. Cool, that's easy to do. But because of the way the IoFog agent was built. But what if you want to move the actual data from one of the pumps to another field, which is about 200 kilometers away, where you want to do some more aggregate processing? You don't really want to bounce that around the cloud. You'd like to move it laterally. And so you definitely want it to be secure. So this layer 7 network that it was created by Red Hat, you can use it separately, but it comes built in with IoFog now. You can just assign a data route between the endpoints that you want to share data. It will traverse, using the cellular backhaul, it will traverse the internet from point to point, but it is logically a direct peer-to-peer connection, right? Just like all of our peer-to-peer, data sharing and stuff, right? Traverses the internet, but it's logically one point to another. And you use this for moving data all around the edge, but you also use it for moving data from the edge to the cloud and from the cloud back down. It's another architectural vision of mine to never have any open ports at the edge. Never have a field that has some network ports open for you to attach to it. Never has a VPN that is connected to some data center somewhere, such that if you compromise the edge node, you compromise the data center. All of these things need to be managed at a much higher level, and so that layer 7's perfect because you really can treat them as part of an application. And so in this diagram here, you can kind of, it's a little bit like architecture, right? Like here's the different edge environments you can have, but the basic idea is that the data flows where you want it to flow, and the control signals flow, of course, up to the IoFog control plane. You can put that control plane wherever. So you can keep it at the edge, you can put it in a data center, you can put it on WAN, you can put it on the public internet, public cloud. A lot of people do that just because it's easy and one and done. But I've said a mouthful, and just want you to know that there are ways to do the edge that you don't have to think in terms of federating Kubernetes clusters, but rather things designed, as we call edge native.
Can I ask you to fill in a little bit more detail on the concept of using Scupper here? Does this take on the, joining protocols from one physical location to another, I gather is a key element it delivers. But does it attempt to dig into what's going on over the protocol and also put up a layer of cataloging of what that data is and means?
It does not. It just carries the traffic. So you could carry like streaming video or MQTT. What you're probably talking about, Steve, is more like Eclipse Hano, which is meant to be managed IoT data streams in which you have an understanding of hey, the protocol adapter here for MQTT is receiving a device has registered and it is authorized. So now I understand the MQTT data stream. Frederick, you've unmuted. Would you like to help?
Yeah, because I think that's a key element here that people, once they enable this protocol to have things pop out at another location, if it comes in this mystery box where you don't even know what's in the box, that just isn't enough, right?
That's right. Yeah, you want some management over the data streams, especially for devices that are not that smart, because something's got to add the understanding, the management layer. Yep, we are working on a grand unified architecture with all of the folks at the Eclipse Edge Native Working Group, and the integration of Eclipse Hano with IoFog would mean it's not that the projects then only work together, it's rather that they can be deployed together with some config that allows them to already stand up. But Frederick, do you want to give some view on this piece here? This is definitely outside the architecture of IoFog. IoFog's architecture is carry whatever traffic, but then the management of it is we see as an application layer. So.
Yeah, and I think that the approach that you've got there is the right one, Kilton, in the sense that really as a facilitator or as a piece of infrastructure, IoFog should interfere with whatever application you deploy on the top of it. So the way Scupper abstracts or overlays on the physical network makes it possible to bridge together in one way all of those disparate networks without disrupting the normal flow of operations. If anyone needs to learn a bit more about Scupper, I put in the chat a link to a recording from Red Hat Ted Ross, the project lead for Scupper. So he spoke at our virtual event in May about Scupper and describes what it can do in a more generic fashion. I think this could probably say a bit more than in the time that we've got left on this call.
Okay, is that the one you just posted in chat?
Yes, absolutely. So that's the recording on the YouTube channel of the foundation.
Okay, thanks. I just transposed that into the notes too.
Fantastic. Yeah. But yeah, I'm certainly excited about what Kilton just described, at the end of his intervention about the potential integration between IoFog and Eclipse Hano, because Hano in the Eclipse IoT portfolio is really our, what I would describe as our message routing platform. So that's a highly scalable component that supports multiple protocol inbound, and then we'll transfer everything to a MQP inbound, in the inside network. And it's already been proven in the commercial Bosch IoT suite. So it's, really scales to hundreds of thousands of devices at the same time, that kind of stuff. So it's exciting to see the potential there for sure.
I'm curious to hear the viewpoints of either you two, and maybe I'm just ignorant of what's already been done and out there, but it strikes me that you put together these tools to make it easy to get these data flows going from one node to another, maybe get some catalogs so you know what there is, but looking ahead one more move on the chessboard, you want to have some governance over it too. Like, who or what is entitled to access this and maybe manipulate it, because some of these might be sensitive data streams that there's some concern over making them literally publicly available to all. There might even be opportunities for a kind of denial of service attacks over these vectors, where if you make it too easy, start instigating additional polling or traffic out at the edge nodes, you might consume excess resources, either on the network pipes or on the compute layer at edge devices that have limited capacity. Do any of these impose kind of access controls or?
Yeah, Eclipse Hano does. Yeah, it's managed message streams and protocol data streams. Yep. You have to, even to join it, you have to have some authentication process for even like kind of like dumb devices that just talk MQTT. And then on the other side, the access to it is restricted, controlled as well. So I think that's the layer. It might not have all of what you're talking about, Steve, because denial of service using devices, right? The device denial of service, attack is we have just seen the beginning.
Yeah, it's unfortunately really popular.
Yeah, and I don't see that vanishing anytime soon. That's the problem. I mean, you want devices in the field, so you have to open the channel. You open the channel, then somebody can abuse it. But I think, Kilton, also the way IoFog has been designed and the way you treat microservices in the edge compute network also helps mitigate those kinds of attacks, right?
Oh yeah, absolutely. I mean, and we're enhancing all the time the different what we call security plugins that you can use to address different concerns, monitoring the network. So, i.e., like talking to the IoFog compute node and watching its in and out traffic. That is something that you can add in such that the agent takes responsibility for watching itself. And the plugins are signed. That doesn't mean that there's not ways to hack, right? We're working on that, but things like changing the file system, overloading its network, or passing too much traffic through it, all of these things, abusing its APIs, cause it to go into quarantine. Quarantine disconnects it from the virtual application network. It goes into a different state where its workloads are paused. You can specify that they get shut down or wiped. But the most important thing is it stops passing traffic around and sends some signals. This is going to be a work in progress for the next 10 years, right, in the way that we address all of these edge security concerns. But the start of it is things like that. So cool. Greg, it looks like you've got to go. Thank you for, I hope this has been a good brain dump from several sources, from Yin and regarding KubeEdge. And
yeah, once again, this was sort of an unplanned one. The agenda said we'd do a Crano, which we never got to, but I think it's been a useful meeting nonetheless. I'm going to time box this. We've got 2 minutes left. So if anybody's got any final things they want to throw on the agenda, please step in right now. I'll take silence as no. And if anybody's got any ideas for things that we didn't finish to carry over into the next meeting, or brand new topics for the next meeting, you can verbally state it or just go scribble it in the notes agenda doc.
Okay, will do. It might be a good thing to actually present what at Edgeworks we've been building with Eclipse IoFog, which is very widespread edge AI smart camera stuff, all on the same principles we've been talking about.
Are you volunteering to do this? If so,
I am, but maybe next time. But if not, the time after. I'm volunteering to do it soon.
Okay. Go ahead and put yourself, you know where that doc lives. So
I do.
Go ahead and put it there on the meeting of your choice.
Looking forward to see that in detail, Kilton.
Yeah. We have been so heads down focused. As soon as I'm available, I want to show. I think it'd be great.
Nice.
Okay, with that said, I'm going to call this meeting to a close. Thanks for attending, and we'll see you at the next one on the Europe APAC time cycle in a couple of weeks. Oh, also, we do have a session at the virtual KubeCon Europe. There's paid registration for that, but I think that this group has a talk, and there may be other things on the agenda for the KubeCon as well. So check that out. Bye, everybody.
Okay, thank you, Steve.
Thanks, Steve.